In this film, we will show you the essential aspects of a helicopter and how it flies. It is important for you to understand this before your first flying lesson.
So, grüezi.
Before you sit down in the pilot's seat, I will point out to you the things you need to focus on prior to and during the flight. Let us start out by mentioning some of the specs of this eminently suitable training helicopter. The Robinson R-22 has been in production since 1973 and is manufactured by the U.S. Robinson Helicopter Company. As a two-seater, it has an empty weight of 880 pounds. It is able to carry a 485-pound payload. Equipped with a 180 horsepower piston engine, it reaches cruising speeds of 100 miles per hour.
The
greatest challenge faced at the invention of the helicopter was how to connect a fixed body to a rotating one. The key component in this design is the Swashplate, which can be moved on all sides. It translates the pilot's steering motions in the cockpit via the cyclic and collective controls. So, what is the purpose of the Swashplate? The Swashplate modifies rotor blade pitch. When the pilot pushes the steering bar of the cyclic control forward, the Swashplate also tilts forward, tilting the rotors forward. Additionally, the rotor blade pitch is adjusted, so the helicopter flies forward. The flying motions to each side are achieved in the same way. The steering bar is pushed to the left or to the right. Such hovering exercises form the basis for flying a helicopter. Note the controlled hand movements used to turn the helicopter into the desired direction. The application of force is unnecessary and may be counterproductive. From the rotor's perspective, we can see the changes affecting the rotor blades. During Swashplate rotation, the rotor pitch changes continuously. An additional dimension of the helicopter's control occurs by means of the collective controls. This control stick is located to the left of the seat. When the stick is pulled, the Swashplate is lifted as well, causing a lower blade pitch all around, which makes the helicopter to move upward. Similarly, the helicopter goes down when the controls are used to lower the Swashplate. Aside from the main rotor, the helicopter also has a tail rotor. The tail rotor prevents any undesired rotation of the helicopter around its own axis. Rotating at a high speed, the tail rotor is almost invisible. Please be careful not to enter into the rotation zone. These zones constitute a lethal hazard. The tail rotor blade pitch can be adjusted, similar to the main rotor blade pitch. This adjustment is achieved by means of the foot pedals. When the pilot presses the left pedal, the tail rotor pitch changes, causing the helicopter to turn to the left. When the pilot presses the right pedal, the pitch changes the other way. Later, in flight, you will notice how sensitive the helicopter's response is, even to very light movements of the controls. The R-22 is powered by a 180 horsepower four-cylinder boxer engine. Since the piston engine is located behind the cabin, it must be air-cooled by this large fan from behind. Power is conveyed to the pulley by means of two drive belts via the drive shaft. The pulley has a clutch, allowing the rotors to continue moving even in case of a stalled engine. The auto rotation is what makes it possible to effect a safe emergency landing. Without power from the engine, the rotors will rotate because of the airflow from below. This results in a downward thrust, reducing the helicopter's drop speed and allowing it to glide to Earth. The helicopter can make a safe and gentle landing by means of a rotor blade pitch adjustment immediately prior to landing. The power from the pulley is conveyed via the drive shaft to a planetary drive system, which simultaneously powers the main rotor as well as the tail rotor. The ratio of the rotating movements is approximately 1:6. The tail rotor rotates approximately 6 times faster than the main rotor. Once we have performed the helicopter's walk-around inspection, we are ready to fly. Just as in a car, the first thing to do is put on your safety belt. In the Robinson R-22, the cyclic handlebar for the pilot can easily be adjusted. You must hold the handlebar in such a way that you can control it smoothly and safely, even during delicate steering movements. Never let go of the handlebar unless you have been told to do so. If, for example, your flight instructor wants to show you something and his hand lets go of the handlebar, then the handlebar must not end up in a position causing the helicopter to make an unintended abrupt movement. Your feet should rest gently on the pedals, parallel to each other. As we have seen, the pedals operate the tail rotor, holding the helicopter straight or turning it in the desired direction. These instruments help us to fly the helicopter. The RPM meter shows engine RPM and rotor RPM in percentages. The speed meter shows the speed in knots and miles. We usually fly in knots, which can easily be converted into kilometers by a factor of 1.8. The artificial horizon shows the flight attitude, and the variometer the rate of climb or rate of descent. In the lower left corner is the altitude meter, which we adjust to the current altitude. In addition, there are some monitoring instruments: oil pressure, oil temperature, cylinder head and governor temperature, as well as the fuel meter. Moreover, the helicopter is equipped with a radio and a transponder for radar identification. The next step is starting the engine, and pretty soon we will be taking off. The helicopter is ready for takeoff, and the flight instructor is ready. We look forward to seeing you and wish you an enjoyable first helicopter flight.